Okay, hello, this is Dr. James, and today I'm going to do some experiments with, I have one of these little induction heaters here, and problem is I've been running it and it's been getting hot, and so I kind of looked up on the internet to see what other people were doing, and some people were using a little submersible pump to pump water through hoses, through these tubes. These are actually copper tubes that can be cooled. And I wanted a way to kind of do an experiment to measure what's going on. So we got a FLIR camera here, and of course, heat takes time, so we have a stopwatch here. And let's just take a look at some of our stuff here. Okay. Okay, so FLIR camera, our induction heater, some hose clamps. We got some hoses over here, a little submersible pump, and a stopwatch, which we can start and stop, hopefully. Yeah, start and stop, okay. Should be interesting. Oh, what in the heck? This just came and looks like it's kind of already opened. Okay. Oh, yes. It's going to make a cooling supply for my induction heater. I was looking online to see what other people did, and I was going to copy what they did. So this is going to be a copy. We'll see if this works. Let's see if there's anything else in this box. I guess, unless it fell out, because this thing looked like it was kind of open before, kind of wet. It's been raining. So here's a fish pump, submersible pump. I was thinking about getting one that runs off a battery, since my source is going to run off of batteries, but I couldn't really tell one of the other sources, or pumps, whether it ran off of batteries or not. And this one I knew worked. And here's some 1/4-inch ID, 3/8 inch ID. I think it should be the right size. We'll have to test it. Okay. Let me open this up. So this will be the tubing that we can pump the water in and out of our induction heater. We'll get this ready to operate at high power. Okay. Come on, what's this going on? Hopefully this tubing is not too big. It's a little bit big, but you know what? Nothing that a hose clamp can't fix, right? It's about the right size. It kind of fits over there loosely, but it's definitely going to have to be clamped. Okay. Let's take a look at it. Oh, actually this came with some hose. Guess I could have not ordered the other stuff, maybe. Looks like it's about the same size here. Okay, so there's a kind of hose. And here is the pump. Oh, that was a little pump, isn't it? Let's take it out of the plastic. There we go. That's how big that pump is. See if it'll fit with this other hose that I got. Yeah, it looks like maybe if I kind of force it on or something, it will work. The other video I watched, they used a heat gun. So maybe a heat gun would stretch it out a little bit. I bet you I could force it on though. But I'm worried about this cheap plastic thing breaking. Okay, we're going to fiddle with this a little bit later, and I need to find some hose clamps to clamp those things on. Some small hose clamps. And we will test out our induction heater with cooling, because I think what's happening when I was testing it before is that the coils are getting hot, and then the resistance goes up, and then you're not going to get as much power into your part you're trying to heat. So all the power is going to start going into your copper coils here, right? And they'll heat up, and then they'll require more resistance, or they generate more resistance, require more power, and it'll be a runaway process. So if we can keep these cool, maybe we can get something else really hot. Should be interesting. Okay. Okay, let's take a look at take a look at some of our equipment here. We have a FLIR camera to measure the temperature, a little water pump, some hoses over here to pump the water through our cooling tubes, and also, you know, heat takes time. There's our medium-sized induction heater, and install the little stopwatch so we can measure the time and get a better idea how this thing is performing over time thermally. Should be interesting. Okay, so here I have a modified Chinese container that I made. I show this in one of my other videos on how to make this, and it's like a GoPro copy camera, and I built this device to mount this camera here to the back of the FLIR using a handy dandy little rubber band, and this hole's right in the center, and I believe it goes something like that, and I'm going to have to put the camera down to get the rubber band around it, and we'll get this FLIR camera up and running. Okay, again, see the rubber band's holding everything together, so it's a real kludge job, but it works really good. It's at the right focal length, and of course you don't want to stick the rubber band across your field of view, because then it's not going to work too well. Okay, let's get this thing all fired up. Oh, I gotta turn the camera on, and the power's on the front. Okay. Okay, it looks like our other rubber band shot away. So, let's get this thing opened. Okay. So there we go. We can measure our temperatures. Get that lined up a little bit with a little camera on there, and look at our coil and see what the temperature is, and we'll be able to measure the time as well, and it should be an interesting experiment. Okay, so here we have our setup. I'm going to use 2 motorcycle batteries, and here's our induction heater, and we'll get our timer ready. Let's see. Okay, so there's our timer, and we'll get this all hooked up and ready to go, and we'll just do a heat test without the cooling first and see how that goes. Okay. And we're taking some thermal images, and let's see what the temperature is. Okay, so let's do just a thermal test of the initial conditions here, and it looks like it's about 79, we'll say 80 degrees Fahrenheit on the coils. Okay. Oh, well, what's this? 73. Okay, so let's get our our cables hooked up here, and of course, we'll do the positive one over here. We'll do positive on that side of the battery, and these things untangle a little bit. I have a jumper wire going between the 2 batteries so that puts them in series, and we'll turn this on and we'll start our timer here. Okay, so the timer is going. Okay. Okay, so there we got our timer going, and we're taking some thermal images, and let's see what the temperature is. We're coming up to, we'll say, at 30 seconds. Let's check the temperature. Okay. Okay, so it was about, didn't really change too much, about 73. Okay. Okay, so we're at 1 minute now. Well, almost. Okay, there's 1 minute. Okay. And I'm still not seeing a change in temperature, really. Okay. The coils seem to be pretty hot, though. Okay. Okay, when I look at it here, it's 81 degrees now. Something smells like it's getting hot. Okay, so we're at 1 minute 45, and it's saying about 74 degrees. Okay. 2 minutes. I don't know, something's getting really hot. Oh gosh, it's hotter than hell. 2 minutes. Let's see, is there anything else that's heating up on this board? Okay, it looks like the transistors. I don't know if this is working properly. Maybe the emissivity is too high for the copper, because it is really, really hot now. Okay, I think I'm going to have to shut it down. It's about 2 minutes 50, and it's probably getting too hot. That's 3 minutes. I'm going to turn this thing off, because I don't want to burn something up, because it is. Ow. It's hotter than I can touch. Okay. So let me, for some reason, the copper must not have good emissivity or something, because it is not measuring temperature. Higher than 80 degrees Fahrenheit. Okay, I guess I had it set for minimum, not maximum, because it's still not measuring that high. Okay, let me redo that test. 108. Yeah, that's probably more like it, because it is freaking hotter than hell. Okay, let's try that experiment again. So, our coils are now cold, and we'll just hook up the power to this guy and start our stopwatch at 0. And we'll look at the coils, and it looks like we're measuring about 81 degrees. Okay, 80 degrees at 0 time. And it's 82, 83, 84, we're at 25 seconds. Still at 83. I'll touch it. Okay, it seems to be getting pretty hot. 95 at 39 seconds. Okay. Oh, maybe it's measuring me. The emissivity must not be very good on these coils, because it only goes up when I'm touching it. Okay, because it's hotter than hell right now. And it's not registering on this guy. Okay, we're at 1 minute, and it says it's only 92 degrees, and it is hotter than hell, I can tell you that. Okay, wait. The circuit's measuring hot, though. It's got 109 at the capacitors. Okay, but that's not what I want to measure. Ow. yeah, minute 25, and it's hotter than hell. I'm gonna turn this thing down again. Okay. Okay, so let's get this thing tested with our water pump here. And I think maybe I'll start out with the cable that came with the water pump, because that one should probably fit onto this nipple thing of the water pump here. Okay, that seems to. And let me put this on the longer hose back here. Actually, before I do that, there's some hose clamps here. I'll get the hose clamp threaded over there, and we'll put this hose up there like so. And let me tighten this guy down. Oh, come on, I should have got him started first, I guess. Oh, this guy's not started. Let me pause for a second, we'll get that started. Okay. Okay, so we got our hose clamp started. Let me just tighten her up a little bit. Okay, so it looks like it's on there good and tight. And I guess I can just use this other hose that I bought. Let's zoom out a little bit. Okay, as a return to our water dish. Let's bring our water dish up here, which I need to put some water into. Okay, and we'll test that out in a second to see how that works. Let me get the other hose clamp onto this other coil of wire, or coil of hose, and hopefully there is enough length here. See, I have about a centimeter length hanging over. I guess that's enough to get the hose clamp on there. Make sure that hose clamp is started. We'll tighten that guy up. Okay. Okay, so I guess there's no advantage to having this hose be a lot longer than the other hose. So why don't we just measure them out together, and then I'll cut this longer hose so they're about the same length, and I can maybe even attach it right to this water pump with a rubber band or something. Return line right there. Okay. And I got a razor blade here. Be careful, never cut towards you with the razor blade. Always keep your tool under control. And there we go. These are about the same length now. Okay, so we have our container filled with water now. And let's just check this thing to make sure that it doesn't leak. We want to check the system. We'll get the return hose back in there, and the submersible pump in there. Okay. And let's straighten this out a little bit. not so messy. And let's plug this thing in and see what happens. Okay. Oops. That's not good. It's shooting water all over the place. I need to tighten up the hose clamp some more. Let me get a towel. Okay, so remember, water and electricity never mix, so don't plug this thing in until it's completely dry again. Okay, you don't want to burn out your unit here. Let's test it. I've tightened up the hose clamps a little bit here. Oh, now it's leaking on the output side. Okay, I guess the output needs to be. It's leaking on this side now over here. Let's see. Okay, see that? It's leaking out there. So I need to clean up that side now. Okay, looks like I have both leaks repaired. It doesn't seem to be leaking out of either one of these places, as far as I can tell. Some water under there still. But I did get water on the board, so you definitely want to wait a while before you try putting electricity on that. Okay, I guess there's our flow rate. And maybe we'll do another thermal test. Oh, I think it's still leaking a little bit. Is it still leaking down there? Oh, yeah, it's still leaking. I gotta tighten that up some more even. Okay. Okay, so I have hopefully my circuit is dried out, and have my thermal camera here ready again, and I'm just gonna, since I think the emissivity is not good for measuring the copper, maybe it's too reflective or something, because there's certain assumptions that you make when you're measuring things thermally with IR, and so I'm gonna take a look at the hoses here and see if I can see a thermal difference once I start up the pump. So I have the pump off right now, it's unplugged, okay, and oops. So here's our thermal, our circuit with the thermal camera here, and we got two motorcycle batteries, and let me just hook these guys up here and make sure our circuit doesn't blow out or something. Okay. And I'll just check this guy, see if he's getting warm. It should only take a second or so. Check the circuit. Yeah, I can feel him warming up already, even though I'm not seeing too much on the thermal camera. Yeah, the coils are starting to get warm. Okay. Okay, just had a few technical difficulties, but I think we got our board back up and running, and it's running at high power. And you can definitely feel the coils heating up. Just running after a few seconds. And here's the hoses. Let me just run it a little bit longer. And I don't have the cooling on right now. I'm just running the circuit to test it without the pump on. Okay, yeah, definitely the coils are heating up. Okay. And so let me take this guy. So I'm going to take the plug and plug him into the wall. And then we'll just kind of watch the hoses coming up to this guy. Okay. And as soon as we do that, let's take a look at the cooling hoses coming out the back. Okay, you can see this one is a lot hotter and this one's cooler. And of course, our water's cooler. You can see the water coming out there. Okay. So you can definitely see a difference in the temperature of the water line coming in, which looks cooler, and the water line going out, which looks hotter. Make sure our circuit is still on, the light's on, and now the coils are definitely cool. So anyway, very interesting. As we turn that guy on. Okay, it looks like, see, one of the hoses is getting actually colder, looks like, and the other one's getting warmer, as we'd expect. Okay. Again, I wasn't really getting good measurement on this guy. You can see the water. You definitely see a difference in the hose color. Feel the difference there. Of course, the water tank is cooler. And let's just take a look here. Oh yeah, the coils feel cool now. So just running that water through there makes a big difference. See, it's not measuring a big difference in the thermal. I think, again. Okay, so when we're testing this, what I'm going to do is I have a ceramic piece of standoff and a iron washer, and I'll just stick this down in the middle of the coil like so. And actually, I may get something to boost it up a little bit because I want that washer to be a little bit more in the center of the coil. So let me get something to boost it up. I just need something to set it on. Let's see. I guess maybe a DVD or something. Okay. So there. So now the washer's a little bit more in the center. And let's try running this circuit with the cooling and seeing if we get that hot washer hot, because I tried to run it before and I wasn't able to get the washer hot. The coils were getting hot. So if I keep the coils cool, it will keep the resistance low so we can get more power into the washer. Maybe we can heat that up. Let's give that a shot. Okay, so we'll get our cooling going. I'll plug that guy in. Let's see, we got the water coming out. And let's hook up, well, let's get our RF camera going, and our thermal camera. And then we will, okay, I'll get that guy turned on. And so here we have our coil, and it's just being cooled right now. And let's hook up the battery. Okay, I got the battery hooked up now. Let's monitor this temperature with our thermal camera. Okay, it looks like the centerpiece is it seems to be hotter than the rest of it. It's at 90, 106, 107, 108, 109, 115. Okay. 122, 124. So maybe the emissivity of iron is something we can measure better with this thermal camera. 126, 130. Looks like the ceramic is starting to get hot now. I'm not really seeing anything on the regular camera. Okay. I bet it's getting hot though. 140. Check and make sure this thing is recording okay. Okay, looks like we're 2 minutes into it. Okay. (150 Fahrenheit). It says it's getting pretty hot. What was that? (160). Let's take a look at our transistors and our board. Looks like the inductors are getting hot down there. The transistors might be getting a little bit hot too. That's getting real hot there. Look, you can see the glow, the infrared glow off the coils, and you can't see that with the normal camera. Okay. 170. Looks like the ceramic is getting kind of hot in there. Okay. You definitely see the return wire, the return hose is getting warmer. For some reason the ceramic is giving off a bigger thermal signature than the iron washer that's heating it up. It's got a different emissivity. Okay. It looks like the components on this RF board are getting a little bit hot. I have to watch that. I don't want to blow out the transistors or something. 175, 178, 180. Seems like it's kind of stabilizing at that temperature. Maybe I need to stick more power into this. I'm only running a 2-car battery, or 2 motorcycle batteries right now. Okay. Let's stop this. Okay, so we got 4-car batteries on there now. And let's just get our ceramic piece. The ceramic's still a little bit hot, and I think I'll just hook up this power to that guy. He's drawing a lot of current. Let's take a look at our washer here. Test it to make sure that it turns on with the 4. Oh, I gotta get both clip leads on, positive to the positive, the minus to the minus. And okay. And it looks like, yeah, our coils get pretty hot quick, and it's drawing a lot of current from the battery. So let's get our plug plugged in. We'll get our thermal camera going again, and we'll test this out one more time. Let's see. Okay. Okay, so we got our water going, and we got our thermal camera going here. Let me just hook up this power to that guy. He's drawing a lot of current. Let's take a look at our washer here. Let's see what we got. Okay, 150, 170. Take a look at the rest of our circuit. Looks like it's getting warm. What are these at? 130, really? 200, wow. So this is hotter than before. 220. 230. Okay. I smell something getting hot. 250. Okay. 260, 270. That's our circuit there. Okay. 280. 300 Fahrenheit. Wow. That would be enough to boil water there. Make sure our circuit's not catching on fire or something. I smell something getting hot. 330, 340, 350. Wow. 360. Oh, something's making a noise over here. 400. 400 and what is that? 430. Okay. So it smells like it's getting hot. Take a look at our circuit again. 200 there. Okay. 460. 470. 480. Okay, we're approaching the max temperature this thing can measure, I guess. Because it was saying max right there. So I guess it can't measure any higher than that. So we might need another way to measure this circuit. I'm going to shut this thing down before I destroy it. There's no sense in destroying this if we can't measure it any higher. Okay. It's pulling an arc off of that battery too. Wow. Okay. This is Dr. Janes, and thanks for watching.